Hi, my name is Tzvi. I am on the chat channel already to answer questions while this recorded talk is running. So I encourage you all to ask questions in the chat during the talk. No need to wait for the Q&A at the end. Hopefully that will improve engagement and understanding. So, let's get to it. This talk will show you a method to turn large language models, LLMs, into useful tools you can rely on for certain B2B applications. It will include very short examples of code or mentions of tools, but it is most definitely about programming and with practical examples. However, it will be mostly programming with human language and not computer language. Just a brief note, my company NEC is a multinational headquartered in Japan, and we have a long history of applying machine learning and AI to B2B areas like biometrics, video analytics, and optimization. Let us start with the problem or mission statement of this talk. If you signed in to hear it, I guess you are already aware of the immense potential and rapid evolution of large language models. It is amazing to think only 2 years ago most of us, even those working with machine learning, AI, deep learning, were not aware of what is coming. And most of us use it. But by use it, I mean as individuals, in a situation where we are in front of a screen, typing, getting a response, and examining it. In many B2B applications, it is very different. The input is a large set of documents, messages, or news bits. The output is not going to be thoroughly examined by a proficient human, maybe not examined at all. It is like the difference between a hand-carved piece of art and an automated production line. For implementers of B2B commercial applications, this brings the following challenges. 1. Decidophobia. If a new better LLM comes out every day, why should we commit as a customer to a solution today? Will it make me look incompetent when a few months from now my bosses find a new readily available better product out there? 2. Hallucinations. We do not really understand LLMs, unlike traditional software. Sometimes they give totally imaginary results which are totally incorrect. 3. Irreconcilable differences. This is not talked about enough. It is a case where the worldview of the LLM is simply different from the one you want or need. To give a simple example, some LLMs will say the color of the sun is yellow and some that it is white. The latter is actually more scientifically correct, but maybe it is not what you wanted. Just to show another real example, this is an actual exchange between our developers and ChatGPT 1 year ago when we were looking into the processing of social workers' visit reports. You will be amazed how much text the state creates and stores about the life, development, and issues of children at risk, and how little it can actually do with these mountains of words. So as you can see at the time, and it has changed over the past year, ChatGPT had strict views about what constitutes a serious physical threat. You can agree or disagree with it, but it simply was not what we needed for the purpose of the application we were building. We focus this talk on applications where we do not want a lengthy generated text from the LLM. Rather, we want, for example, an answer of yes or no to a question like, can I bring pets with me on the trip? Or we need to examine a large set of documents and classify them to categories. Another example is filling up data tables in a SQL database or Excel sheet from a free-form report an insurance agent or a physician wrote. Then there is data extraction, which is almost completely done by human labor right now. To give a real-life example, before appearing in court, policewomen may spend a lot of time going over all the different testimonies, making sure there is no discrepancy in some basic information like times, dates, or names. Such errors can easily disqualify a case in court. Now, the accepted wisdom is that if the LLM does not do what you wanted it to, it can be tuned or trained to suit your goals. This is sort of true, but it takes much more effort than many people realize, and the result is not guaranteed to be perfect. When you have a bug in your code, You are supposed to work with your mind and fix it, and hopefully it is done. With LLMs or any other machine learning AI training, it is not exactly like that. The fix may involve a very large effort to create many new good examples of text that will teach the LLM what you want it to do. Then, even if you spent all this effort, or worse, if you told your customer they should do this work, sometimes the tuning is still not perfect. Everyone who ever worked with machine learning knows this, but our customers have a justifiably hard time accepting it. If you have a problem in your car or a bug in your ERP software, you expect as a customer that it will be solved, done, period. So how do we claim to solve this? We treat the prompts to the LLM as programming commands, and just like in coding, we try to make the results very predictable in format and as accurate as possible. And we pay for that by painstakingly breaking down complex questions into a list of simpler ones. In the examples I'll give, we'll have binary answers to the questions the LLM can give, 0 or 1, or in our case, yes or no. We then improve the reliability of the yes-no answers by asking similar questions in different ways or with different parameters of the LLM. It's a bit like a first responder interrogating a dazed accident victim to make sure about allergies or what happened. Having run all these questions by the LLM, we then run the results through a pre-trained or predefined classifier to get our final judgment on the original complex questions we wanted answered. The great benefit of this method is you can debug the individual questions and answers and the error cases. You can fix systemic errors by changing or adding questions. Very similar to coding. Let's for a moment go through the data flow of our method. Our input is a document to process and our list of closed form questions or prompts. We run the prompts on the document using an LLM, getting a list of yes, no, or 0, 1 answers, which form a vector. This vector is then fed into a classifier, which can be, for example, a random forest, KNN, rule-based system, or a combination of all of those. When our prompts are for data extraction, there will be some merger logic for the LLM answers rather than a classifier, but that is not covered in our current talk. So, from this simple diagram, the key benefits become clear. First of all, we can replace the LLM if we want to, use a newer one, a different one, switch from a public LLM to a private cloud on-premise system. The only thing we need to retrain is the final classifier on our already existing set of test documents. This can take hours of LLM work and may cost you hundreds of dollars, but not hundreds of thousands of dollars, which is what actual LLM training costs. Then, by being able to switch to a private LLM, you get the kind of security B2B expects. As we mentioned, you debug by adding or changing prompts. You do not touch the actual LLM at all. Let's do a quick example that people can also try themselves later. One of the greatest contributions of the United States government to the field of natural language processing was making available the Enron emails dataset. Enron was a public company that crashed in 2001 due to a giant scale and long-running series of frauds. Now, assume you want to use an LLM to scan through all these emails and find the ones potentially related to the fraud planning, activities, or cover-ups. Most of the emails are mundane, typical corporate communications about office party or even discussions about very personal matters. We do not have time as people to read through all of them. But just asking the LLM, is this email about fraud, will not work. And even if you add to the prompt some definitions of fraud or examples of emails discussing fraud, it doesn't do a good job. Why? Because humans have a lot of understanding about the real world, about how people communicate and think, and it's very hard to teach those to an LLM. As you can see in the bottom, we create a long list of guide questions with yes-no answers. These are questions which we hope the LLM will answer mostly correctly. The actual list is longer and can include dozens or even hundreds of questions. You don't have to think about all of them at first. You start with a few, run the system, find cases it missed, and then figure out the additional questions. And then code new questions to handle the cases you didn't think of in the first place. Let's now do a single detailed example. I apologize for using MATLAB, which is a great product, but not an open source one. However, the code is so simple one can think of it as pseudocode. It is completely possible to do everything I've discussed using purely open source LLMs and Python code with libraries. So you can see 5 prompts in the string array SP and 2 sample emails in the array MES. We then iterate all the prompts over all the emails in the list. Note our final prompt to the LLM is just the welding of the prompt to the email. When we look at the vectors we create, we see that indeed message 1 was correctly identified as related to legal matters, while message 3 is also legal but also personal, so of no interest to Nancy Drews like us, which are interested and looking for corporate fraud. Just to give a taste of the real complexity of B2B work, see this real Enron email. It is long, not perfectly structured, and hard to follow if you are not an experienced Enron employee in the area of pricing methods. Initially, our prompts did not cover it since we didn't understand as software developers the critical part of pricing methods and regulations in the operation of a company like Enron. But once a customer tells us about it, we added a question about pricing discussion, to which the answer of the LLM is of course yes, and that triggers the classifier to further examine it from other aspects. Now, even when we build our prompts carefully, LLMs are not compelled by some law to answer in the format we requested. It can be minor things like answering yes in lowercase, uppercase, with a period, without, etc. It sometimes occurs that LLMs will simply start a long answer rather than the yes or no reply we are looking for. Again, remember there is no patient employee looking at the LLM answer to think and summarize it afterwards. It must all work automatically like normal computer code. So, turns out that before every word the LLM outputs, it actually calculates a cloud of probabilities for different words and chooses one based on either a simple maximum or greedy approach or other methods. So a well-known technique that comes to our aid is masking. We simply eliminate all the words that we don't want from consideration, allowing only the strictly affirmative or negative one-word replies. To show a simple example, we take BERT, a well-known decoder-only transformer model, which is considered good at guessing missing words in the middle of a text. In this simple case, when prompted to replace the missing adjective about the sun, BERT proposes bright, which makes decent sense given that we said the sky is dark. So on the right-hand side, we look at the most probable words BERT was offering and consider only colors because that's what we want in this case. Then we get that red and yellow are the best options BERT would suggest. The red option may surprise at first, but we did say in the sentence the sky is dark blue, so maybe we are talking about dusk or dawn, and there the sun is on the horizon. So we were masking all the options except for colors to make sure we get the kind of answer we want. Once we have the system, how do we actually train, test, debug the classifier? We have several options here. We can define manually some rules. For example, if the email talks about financial transaction and is not personal, mark it for further inspection. Or if the majority of legal related prompts get a yes, consider it legal and mark for further inspection. This gives you tight control and easy, rough working first version. Second option, you can take samples you have and use a public LLM to augment your classifier training and testing with variations that the LLM public one will generate for you. You can then use it to create all your samples. If you prompt ChatGPT with something like, please generate an email from a salesperson to a customer about a debt with suggestions to restructure it, you will get very reasonable results. You can then ask to change the tone, the urgency, the type of the company, etc. Third option is for testing. Such quickly generated LLM sets are ideal, and you can use the power of combinatorics to generate almost an infinite set. However, note all these examples are based on your preconception of what the text may entail. If you never heard or thought about pricing discussions and you didn't ask the LLM to create them, they will probably not create them for you. So using a public LLM to create more examples can improve your training and even avoid having to get real samples, but it's not perfect if there are special cases you just didn't think or know about. And as in any programming environment, we need to be able to debug. In normal LLM use, this is impossible. There is no known method to single step into and explain why an LLM answered as it did. Leading LLM developers like OpenAI, Google, and Microsoft are working hard on adding references from external data to justify factual statements. But if it is about reasoning, most LLMs, with latest ChatGPT a notable example, are not so good at explaining themselves. And in B2B, we will probably be using some open source, more limited on-premise or private cloud LLM, which can't explain itself. But since we broke the task into simpler ones, we can tackle this. When we are told the classification was wrong, we first look at the answers to the prompts. If some are wrong, we can try to see if it's an LLM specific issue or general. We may add some similar prompts in the hope that an ensemble answer will on average be correct, just like asking a person repeatedly about something when they are dazed or sleepy. For example, if we asked, is the document referring to legal topics? We may choose to break this down to questions about litigation, contracts, court processes, letters received from lawyers, etc. In some cases, it will be the classifier that is in error. That may be enough to solve it, as a classical programming error. For a given vector input, the classifier needs to give a specific output. The important thing is we do not, under any circumstance, need to sheepishly go back to the customer and say, can you give us more examples like that? We want to tune our LLM better. I honestly cannot overemphasize how important that is, not to bother your customer with asking for more samples or explanations. Let us do an example. Carefully reading this short email to Wanda, as humans, we can guess this is a personal matter and not a discussion about some corporate deal. It seems the author was hoping or hinting at a promotion that would improve their financial situation. For example, ChatGPT 4 is clever enough or human enough to realize this, but ChatGPT 3.5 and many open source LLMs are not. We will encounter cases like that throughout the implementation of real B2B LLM processes, where as humans we know the answer, but the LLM finds it hard to always get it right. So we can try to use a smarter LLM, tell the customer to live with it, or use the time-honored method of programmers have always used since the first UNIVAC computer with vacuum tubes was built. Hack a workaround to handle the special case. In this case, we put a special prompt to detect texts that talk about HR changes for the author of the text. Again, in an ideal world, the LLM would have simply been clever and sensitive enough to understand the reference to promotion, rank, status makes this a personal matter. But we are not in an ideal world, so we need to tell the LLM exactly what we are looking for. Yet another advantage of using simple closed-form prompts is that for debugging at least, you can gain insights about issues by using the latest public LLMs like ChatGPT 4.5. Although they may not be the LLM you are using for production, by asking them why they got some question right or wrong, you may get insights in how to patch your own LLM deficiency on the same matter. So when we asked ChatGPT about a similar personal email to Wanda, why it thinks it is personal, we get a very detailed and complete answer. The author addresses the recipient on a first name basis, he expresses his feelings of worry, he refers to his own financial situation, and the message in whole is about a decision-making process which seems personal. A very long answer which may give us insights, but not that useful for programmers. Turns out we can corner ChatGPT to give us a simple, even if incomplete answer. And it does. The key tell in the email was the mention of a promotion. ChatGPT knows in the context of this email this is a personal matter. Now we can take these insights and try to build simple prompts to detect such topics or similar ones in texts and see if our local LLM with this help can figure it out. We are effectively using the top LLMs that the world has to offer as our debugger, and presumably in the future this capability will get even stronger. The smart public LLM can help us train better our simpler on-premise private LLM. As a final thought, we point out latest code LLMs can help you create the classifier code itself. For those of you who are not programmers or simply seek a smoother process when using libraries you are not familiar with, this is an attractive option to consider. For brevity, we provide a trivial example of CodeGPT generating a Python sample for basic logic. But you could try more complex requests to incorporate, for example, the use of k-nearest neighbors or random forest algorithms, and you will get probably nice reference code. So for people who did not use these libraries or build classifiers in the past, that is an attractive option. Even more provocatively, we may do away with coding altogether. As this example shows, a modern, full-blown LLM can execute logic on its own without writing Python. And using new function calling and API features, it will be able to use external algorithms and libraries. Now, of course, execution of logic by an LLM is very resource intensive and slow. It may not make economic sense in most situations for production. But it does empower non-programmers to try to define the application logic by themselves. Imagine the customer trying different variations in their own words, learning the limitations, offering something that suits their policy better, or simply just finally understanding how hard our work as the implementers actually is. So to sum up, we have shown a programming approach to using LLMs in some B2B applications. These applications require much higher accuracy and success rates as the process is without human supervision for each step. We break the task to small manageable prompts and classification steps, making the debugging or tuning more tractable. And just as importantly, we reduce the dependence on a specific LLM or version, which is exactly what you should want in a world of such rapid change or growth. Topics that are still under active research at our NEC labs are applying similar processes to tasks that require more informative LLM results. For example, data extraction from the text, not just yes or no answers. We are also working on trying to more automatically convert a well-written policy into a set of prompts. Think of it as training sessions to new interns who are required later to do critical but repetitive tasks. If your policy is clear enough, you only need a few examples to get the message across. Imagine it could have been the same in the future with LLMs that are coming our way and new techniques like those we are trying to develop. Thank you, and now we will move to the Q&A session.